This is AlphaKoala, just going to make an informal video response for Module 2. Now we're going to be covering half the questions. We're going to have a look at 3, 5, 7, 8, 11, 12. I'm not going to focus too much on actually doing the questions or teaching too much of the theory behind them. I'm just going to kind of go over a lot of problems people are having. And that's because it'd just be simply unfair if I just gave you the answers. Just because a lot of people spend a lot of time on this, and I don't really want to upset them. But at the same time, I want to make sure everyone has a good chance to finish it. So I'm just going to go through a lot of the problems people were having. Okay, so let's start with question 3. Now the question asks you to find the moment the force at A causes it at O. The moment AX and AY. Sorry. It asks you to find the moment force of AX and force of AY causes it at O. And that's just its X and Y components. Now, to do that, if you got the horizontal force, you know the vertical distance, it's just going to be horizontal force times vertical distance, and sorry, its vertical distance will actually be over here, and that will affect it. And that's because you're going to have your force going against the distance that way, and that's going to make that a negative value. Whereas this has a horizontal displacement of that, and that's going that way, so that's also going to have a negative value. And I think that's right. If not, that's okay. Now, a problem a lot of people are having is they're moving the force over here. And that's a later part of the question. That's not part 3A. And that will give you the same total moment about O, because it lies on the same line of action. So normally that would be fine in a question. But because it specifically asks for force A of X and force A of Y, you have to leave it A, otherwise it'd be force BX and, force B of Y. And even though they have the same magnitudes, they won't have the same displacements, so their moments will, in fact, be different. Okay, so that should answer most of the problems with question 3. Okay, so let's jump straight over to question 5. And question 5 gives us a pipe. Alright, and the pipe is going to have a moment in the middle, we'll call it that way, a vertical force here, and a diagonal force here. And it asks you to replace these forces in moments with a force or moment about point A. And we'll call that A. Okay, so what do you have to do? If it's asking you to find a resultant force of these, well, you're just going to have to add them. So first, I would recommend finding the vertical component of this force, and adding it to the vertical component of this force. And that'll give you the vertical force on A. Then you got to find the horizontal component of this force. And if you already know theta and this magnitude, that shouldn't be too hard. And then put that over at A. So then you know A is moving in that direction. And you can calculate that with Pythagoras. And you can work out the angle in there. As for the moment, the total moment about A will be the moment caused by this. So that's a vertical force, so you take its horizontal distance. And that will be negative. Then you take the moment of this. That will be that distance from point A. That will also be negative. And you add this moment. And that will give you your total moment about A. And that's written, the sum of moments about A equals, that'll always be that plus that plus that. So, that's not too hard. And at this point, if you're not understanding, you should probably go look at my other video, which kind of explains the concepts behind moments and stuff, so you kind of know what I'm rambling about. Because it's kind of unclear how I'm saying it, but you should be getting at least some idea. Okay. Question 7. Okay, now this is a nasty question. And what you're going to have to do is there are kind of 3 things to look at. Firstly, there's the triangle. Firstly, there's a rectangle. And we know from, elementary school, we can calculate the area of the rectangle, which is just base times height. And if your height is in newtons per meter, so we'll just call it 6 newtons per meter, and your length is in meters, we'll call it 6 meters, then base times height is going to give you, 6 newtons per meter times 6 meters, which will cancel out the meters, and you'll have 36 newtons, which is a force, and that's what we want. So to calculate the total force, we just calculate the area. And, because it's a rectangle, if the force is uniformly spread, it'll act straight down the center. And that's probably fairly intuitive. Okay, now we have to look at triangles. Oof. Okay, now it's too lazy to do triangles. Base, height again. The area of a triangle is equal to base times, that's a times now, times height over through. And that's just because it's half a rectangle. Now, the resultant force will act over here. And that will be 33% of the total distance in there. So if this was 10 meters, that would be 3.3 meters. Or if this was 9 meters, that would be 3 meters. So that would give you 33% from the big side. And you can take that as like a rule of thumb or an identity rule. Or you can go a little bit more hardcore if you wish. And you know the formula of a triangle equals y equals mx plus c, because it's just a straight line function. If it starts at 0, then c is going to be 0, so that's negligible. It ends at, 10 meters and has a height of, 6 newtons per meter. So you can go, well, if x equals 10, then y equals 6, and you can calculate what n is, and then you get a function. Alright, and you're kind of like, well, I got a function, so what do I do with a function that's not really that helpful even remotely? And that's fine because it wouldn't be, unless there was a beastly textbook. And in the textbook you will find a beastly formula. And the formula looks really scary. And I'm not going to write it up because I'll probably mess it up. But if you look through your textbook, you will find two integrals, and that will, find where your resultant force is, and that will verify that triangles is, 66% of the total distance across. Okay, so you got a shape that looks like this now. What do you do? Well, you can use the formula again and go y equals mx plus c, whereas this length here will be c, because that's, when x is 0, that's the height. Or you can separate into a triangle and a rectangle, and just calculate them individually and add them together. Personally, I like to just use the triangle and rectangle because the formula scares me a little bit, and I'm okay with that. But, regrettably for part E, you're going to need the formula. And, actually, for part E, you probably won't need the formula. For part... no, I would say you probably could do part E without using the formula. Yeah, you could. Okay, so for part E, you don't actually need to use the formula. It's a symmetrical load. And if it's symmetrical, then the total force resultant will act straight down the center. Because that's just like your rectangle. Because it's symmetrical, straight down the center. And that's not too hard. However, you get given this as a function. And you know the area under a curve is equal to the integral of the function between, point A and B. So say this function is, x squared plus 4. The area under the curve would be the integral of a to b x squared plus 4. And that's in the textbook, next to the other formula I mentioned. The other formula I mentioned, like I said, it's really big and scary. I would try to avoid using it wherever possible. I don't think you're ever required to use it. There's normally ways you can kind of get around it, but, if you want to look at it and kind of use it, that's fine too. We're not gonna judge. Okay, so moving on to question 8. Now, question 8, this is where two force members come into this. And if you don't know anything about two force members, you should probably go and watch my video on two force members, which I will probably have online soon, because otherwise you will spend a lot of time staring at pictures and not knowing why you're getting it wrong. And I know this from experience because it took me about 4.5 hours to do part C, and that is simply too long. Okay, so you got two force member. You have three equations of equilibrium. The sum of y must equal 0, that's your vertical forces. The sum of x must equal 0, that's your horizontal forces. Okay, and the sum of moments must equal 0. Well, the sum of moments at any point must equal 0. So, for two force member, it's actually pretty simple once you get your head around the idea. So, if I had a force here, and it's got two components, right? One going down and one going across. And we'll say these are 2, and that's 2. And then I have another force here. And that's got 2, and it's going across 2 as well. So it's, there. Okay, now you can look at this and go, well, I got a force going down of 2 and a force going up of 2, so the y is a balance. You got a force of x going across of 2 and a force of x going across of 2, so the x is a balance. So, it shouldn't be floating up or down, right? But if you took the moment about point A, these forces become negligible. This has no vertical distance, so this is negligible. But then you have this force left over, and that's going to be spinning your bar around. So, basically you have a bar spinning around, so that's not really in equilibrium. That's slowly accelerating in a spinning manner, and that's bad. So what you're going to do for a two-force member is make sure that the forces lie on the same line of action. And what do I mean by that? I mean, if this force is going this way, then its line of action is going to be here. Let me just kind of stretch that up. So, if that's theta, then that is also going to be theta. And I know that's probably giving away too much of the question, so that's kind of bad of me, but that's really the only way to explain it. And that's more of a concept than actually a question. That's, two force members. If you want them to not be spinning, they have to lie in the same line of action. There is one situation where that won't be the case, and that is for parallel forces. So I'll just draw my line here, And if you've got a force going there and a force going there, and you're taking it out here, then those moments are going to cancel each other out, even though, they're not in line. Though I'm not even sure if that's a two force member, so don't actually quote me on that last part. I didn't plan to put that in the video, I kind of just spurred the moment forward of it, and I think it might actually be wrong. But I'm not going to worry too much about that, because I'm going to power on to 8C. And 8C was the scary question. This is what most people don't know how to do, this is what took me ages to do. So, feel glad that I'm kind of going to help everyone with this. Now, if I'll just draw my diagram. Alright. Alright, that looks good. BBA. Oops, that's F, that's G. Alright, so you've got your question, and it's looking pretty scary at this point. You've got a force of P going down, and you're kind of worried. And that's understandable, but remember what we said about two force members. So the first thing you want to do is identify the two force members in this scenario. And if you look, there's only going to be two forces acting on this member here. And we can ignore the fact that, you know, it's a circle. And we can say that this and this will be equal. I actually took my two force member in the wrong spot originally. So I'll just go over my way and, you know, we'll see how that pans out. Because I don't really like using the circle. Even though the circle's not really going to affect it, I just don't like using it. So I just put mine over here, and it's technically incorrect, I think, but, you know, that's fine. Okay, so if these forces acting on this are going to be in the same line of action, then they're going to have to be, you know, one that way and one that way. Because otherwise you have one going that way and, you know, one going that, like if you have one force going that way and one force going that way, they're not going to be in the same line of action. Those are never going to cross. So the only way these two forces are going to cross is if they're going directly horizontally. And that was a little complicated to say, and I kind of screwed up this question a bit, and I'm sorry for that. But we're going to power on anyway, because we are tenacious. Alright, so you know that the force along this is going to be horizontal, which means that the force of G will be horizontal. So we'll act in that direction. And you know that the sum of all y is equal to 0. Therefore, and this is P plus a dy, which is going to be acting that way because it's got a counter P, will equal 0. Right? So if you know the value of P, you can calculate dy, and you do know the value of P, so you can calculate dy, so that's not going to be a problem. The next thing you're going to want to do is calculate the total moment about A. And since P is acting on A, that's not going to cause a moment. Since this is horizontal and has no vertical displacement from A, that force is going to create a moment. So the only two forces creating a moment will be dy and dx. Now you don't know which way dx is acting at this point. You don't know which way fg is acting at this point. And that's fine, because if you look at it this way, this is kind of creating a moment that's positive. So then the other force will have to be creating a negative moment to keep it in an equilibrium. And to create a negative moment, it will have to be acting that way, which does not seem right. Just one moment, sorry. Alright, well, I'm not sure if I'm just doing it wrong now or if my notebook's a little bit wrong, but anyway, we'll just power on. So that's going to be creating a force that way. So then your total moment about A will equal 0. And you know that by calculating these two distances. And if you already get the value of this, you already know the distances, you can calculate the value of dx just like that, just by using the moment equation. But you're not quite done yet, because you still got to find out the value of g. And you got your last equilibrium equation. Sum of x equals 0. Therefore, dx plus f of g. Sorry, these should really be called f of dx and stuff. Getting a bit slack, but that's fine. So dx plus fg will equal 0. So, you know, you can say that if dx is going that way, then fg must be going that way. So dx equals negative fg. Alright. So now you know the value of fg. You know the horizontal and vertical components of the force at D. So if you know its horizontal component, you know the vertical component, you just use Pythagoras and find its magnitude. And those should give you your answer. Hopefully that was reasonably clear. I'm not sure that it was. But that's what I get for making a long video. A lot of screw-ups and not a lot of time to fix them. Okay, so we're going to go to the next hard one that I found people having trouble with, and that's question 11. And simply put, question 11 is a nasty question. It looks scary because it is scary. So I can't really fix that, but I can try and, you know, walk you through it. So we got a wheel here. We got a point C up here, right? We have force acting on that wheel in the upper direction. And I think your other force is acting this direction. So that's 2. That's 6. Alright, you got point A here. You got point B up here. And I think point B was acting that way. Okay, now you're probably looking at my diagram going, well, why haven't you got a line connecting B to A? And you'll see why in a moment. Pun not intended. Okay, so firstly you got to calculate this vertical distance, and that shouldn't be too hard to calculate. Then you're going to use this angle in here to calculate this horizontal distance, and that should be pretty easy as well. And the reason we're doing that is because instead of doing part B first, we're going to jump straight to part C. Right? And the reason we're doing that is because if we look at the moment about part C, we can instantly rule out the forces at part C. These two forces will create a moment. That's fine, because we know the distance, we know their values, so we're going to be able to calculate that. Our only variable will be the force FB and its components. And if we just translate this over to A, and remember how we discussed before that you could move it along its line of action and it'll still create the same moment. So we're going to translate this over to point A. and that's going to be force F, or force AB. So if we know this angle in here, this will be FAB sine theta, and FAB cos theta. And the reason we're turning these in terms of FABs is so we only have one unknown variable. And by doing that, we can calculate the value of FAB, because it's our only variable. So if we go, the sum of moments about C, the sum of moments about C will equal 0. We can use, all those to kind of work out what FAB is. And once we have FAB, it's not going to be very difficult, because we know that the sum of y is going to equal 0. We know this y, because we got FAB. So then all we need to do is find out the y vector of the C. And we can do the same thing for the x. So then we got our x and y vectors, and yeah, there's not really too much of a trick to that. The only part that will get confusing is in here, right? So we've got our force AB going across, but we need to know the horizontal distance from, the vertical distance from C. And that's just going to equal, if I draw over my image, that distance in here will be the horizontal, and this distance here will be the vertical. So you just got to remember that, to calculate those two distances as their own separate triangle, kind of in line with your triangle. So it's kind of a messy diagram, but it gets the job done. You can probably find tutorials to that question online. It's not a hard question. I'm actually going to do a video on using online resources soon, so hopefully you'll watch that and kind of get a feel. Okay, last question. Question 12C. And question 12C is a little scary. The first thing you want to do is break it up into 3 forces. Alright, and your 3 forces will be area 1, area 2, and the weight. And you just look at weight. Well, we weren't really given a weight. Well, you're given a mass, and you know what gravity is, so you can calculate weight. Since the bar is uniform, weight will act at the center. So you got weight. Don't forget the weight, because if you forget the weight, things will be bad. Okay, so area 1 is a rectangle, so you can calculate that, just base times height, and it'll act in the center. So area 1 total will act down here. Area 2 is a triangle, but we don't know the value of the height, and that's what we got to try and solve for. So we know that the area of a triangle equals base times height over 2, and we know the base, but the height is going to equal to, I think that was W1, W2. Okay, so the height will be equal to W1, take W2, and that'll all be over 2, and that's area 1. Area 2 equals that. And since it's a triangle, it's going to be acting at, this distance, which is 66% of your total distance, or 33% from this point. And if you calculate, half the total distance will be the, distance between here and the force resultant. Half the total distance will be the distance between here and the weight, and a third of the distance between here and here will be the distance between the force resultant and this. And once you have that, you can rearrange this in terms of weight 2, in terms of weight 1. And if you rearrange, you get 2 times area 2 over B, take weight 2, equals weight 1. Alright, so that's kind of like the initial stage of the question. And that should scare you, because that's only the initial stage of the question and not the entirety of it. But, they had to put a big question in right at the end, and this was it. Okay, so hopefully you kind of know what I did there. And if not, I'm sorry, but this is probably approaching my camera's time limit, so if I don't rush through these, I just won't fit it onto one video. Alright, so the next thing we're going to have to do is know that it's AlphaKoala here, just coming back, the camera cut out, sorry about that. Okay, so the next step is you have the tension of the rope supporting the beam, right? This is 1250 newtons. We'll just give it a random number. If you have feet, you can easily calculate the vertical distance of it. So we'll just call it the y component for now. Okay, so now you've got the y component of this, the vertical force. If you've got the vertical force of this, you've got its distance from B, you've got all the other vertical forces except for area 2. You can then rearrange the formula simply to calculate area 2. And once you've got area 2, you can substitute area 2 into your formula before, which should have been something like area 2, 2 times area 2 over 1.6 minus plus W2 equals W1. So you've got area 2 now. So you can use that to calculate area 1. You can use it to calculate weight 1. And since you've got all the y components, you can then use the sum of y equals 0 to calculate the magnitude of the y. And that will be the end of your question. If you have any more questions about any of the topics I've discussed during this video, just send me an inbox and I'll be happy to reply. Alright, AlphaKoala out.